Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to subscribe and share my videos to your friends and to your friends' friends. That's the only way you can help me promote my channel and to keep me going, refreshed, and inspired. And I'm very willing to share my knowledge, especially topics in civil engineering for your benefit. The left half of the simply supported beam carries a uniformly distributed load of intensity 600 newtons per meter. So letter A, compute the value of EI delta at midspan. Letter B, if the modulus of elasticity is 10 gigapascals, determine the smallest value of moment of inertia that limits the midspan displacement to 1 over 360th of the span, or L over 360. So here is a given figure. Let's have AY here, AX is 0 obviously, then we have R sub C. So we'll just compute AY, summation moment about C equals 0. So we have A equals AY times 8 minus 600 times 4 times 6. So 2 plus 4 is 6. So solving for AY equals 1800 newtons. Then let's section this part so that the equation is continuous, and we extend the load. We also counter it by the same value. So this is also 600 newtons per meter. Therefore, the differential equation EIY double prime equals 1800 times x plus 600 times x minus 4 times x minus 4 over 2 moment arm minus 600x times x over 2, moment of the upper load with respect to this section here. So simplifying EIY double prime equals 1800x plus 300 quantity x minus 4 square minus 300x square. Integrating EIY prime equals 900x square plus 100 quantity x minus 4 cube minus 100x cube plus c sub 1. There is c sub 1 because there is slope at A definitely. But there is no c sub 2 because when x is 0, deflection at A is 0. So integrating again, EIY equals 300x cubed plus 25 quantity x minus 4 to the fourth minus 25x to the fourth plus c sub 1x. Again, there's no c sub 2. Then let's evaluate c sub 1 by the boundary condition when x is 8, y, c is 0. So 0 equals 300 times 8. 8 cubed plus 25 quantity 8 minus 4 to the fourth minus 25 8 to the fourth plus c sub 1 times 8. So solving for c sub 1, 25 times 8 to the 4 minus 25 times 4 to the fourth minus 300 times 8 cubed divided by 8. So c sub 1 is equal to negative 7,200. That's Newton meter square. Substitute into this equation, AI. Then compute for delta max, which delta at midspan rather, where x is 4. So 300 times 4 cubed, this is 0. Then minus 25 times 4 to the fourth. Then minus 7,200 c sub 1 times x, which is 4 at midspan. So EI delta at midspan is equal to negative 16,000 Newton meter cube. So the negative sign indicates that the deflection is downward. Then for part B, EI delta midspan equals negative 16,000 Newton meter cube. So E is 10 times 10 to the 9 pascals. So EI times negative L over 360, because this deflection is downward, of course, equals negative 16,000. So cancel out the negative sign. Substitute the value of E, which is 10 times 10 to the 9 Newton per meter square, times I in meter to the fourth, times L, which is 8 over 360 meter, equals 16,000 Newton meter cube. So I should be in meter to the fourth. Solving for I is equal to 7.2 times 10 to the negative 5 meter to the fourth times 1,000 to the fourth to convert that to mm to the fourth. So it is equal to 72 times 10 to the 6 mm to the fourth. So that's it for this problem.